Out there in the gigantic obscurity of space, the James Webb Space Telescope has been exploring the slightest items for replies about the universe. This NASA's new eye above has been finding astonishing pictures of stars, massive planets, and planets. Finally, something startling has been found, something so immense it could shake the actual spines of all that we comprehend. It has researchers scratching their heads and surveying whether it could incite the farthest prerequisite of everything. Go along with us as we investigate how the most recent disclosures of the James Webb Space Telescope could crush our comprehension of the universe. When we investigate the edge of the universe, we are discussing the recognizable universe. The noticeable universe appears to be a window through which we can take a gander at the extent beyond the detectable universe. It envelopes all that we can as of now see, measure, and explore utilizing our telescopes and space tests. It's an assortment of stars, systems, and grand bodies within our grip of seeing. Nevertheless, the discernible universe is only a little piece of the whole universe. Imagine it as a slice cut from a gigantic pie that we're able to study and grasp. While the complete size and state of the universe at large remain a secret, researchers estimate the width of our discernible air pocket to be around 93 billion light-years. A light-year measures the distance that light, the quickest thing in the universe, goes in 1 year around 5.88 trillion miles or 9.46 trillion kilometers. So, when we talk about the breadth of the detectable universe being 93 billion light-years, we're discussing a gigantic stretch. Around 13.8 billion years ago, the universe burst into reality in an unthinkably solid effect. This event began what we call the Big Bang. Since that huge birth, the universe hasn't just been growing, it's been advancing quickly in its development, confusing powers like the strange dark energy, which appeared to be driving the acceleration, extending the limits of the universe further apart. As the universe extended, matter began to cluster together, influenced by gravity. This gravitational force joined particles, birthing shocking designs. Stars, huge systems, and, in the end, planets like our own Earth. Picture the universe passing by as these huge structures framed, developing into the special yet continually developing peculiarities we see across the universe today. Regardless of its immense size, the universe is staggeringly void. If we somehow happen to recoil our whole nearby planet group to the size of a quarter, the closest star would still be about the length of 2 soccer fields away. This endlessness broadens right inside our own Milky Way galaxy, which is only one among billions in the discernible universe, providing us with a feeling of the sheer size of limitless space. Now, you might inquire, why can't we simply see all that exists in the universe? There are a few purposes for this limitation. Most fundamentally, light, the fastest thing known to man, still takes time to travel through space. This implies that when we take a gander at far-off objects, we are essentially concentrating on the past. The farther an object is, the more time its light has taken to contact us. It's like glancing through an immense time machine, unrolling the history of our universe. As we notice systems millions or even billions of light-years away, the genuine universe is extending. Imagine spots on the external layer of a growing inflatable. As the inflatable swells, the spots move farther apart. This same rule applies to the universe. Worlds, like those spots, are floating separated as the texture of space extends. This extension causes the light from far-off objects to go through a shift known as redshift. Basically, the frequencies of light stretch as the objects move away, moving toward longer frequencies, frequently seeming rosy in color. Given these factors, light's movement time, the development of space, and the universe's constant expansion, it's to be expected that we haven't yet fully seen all that the universe brings to the table. Even with our especially advanced telescopes and technology, our view is still confined by these critical properties of the universe. The journey to grasp the conceivable edge or boundaries of the universe has captivated the minds of endless individuals across disciplines. While conclusive responses remain slippery, 3 noticeable speculations have arisen, each offering interesting points of view on the expansion of limitless space. The first hypothesis suggests that the universe expands gigantically, continuing endlessly without a noticeable edge. This thought aligns with the cosmological principle which states the isotropy of the universe, that it appears consistent from any vantage point. If this principle holds, it suggests that the universe lacks a limit and continues expanding infinitely in each direction. The second hypothesis offers an alternative view, proposing that while the universe may indeed be limited, it lacks a clear edge. Rather, it might resemble a huge circle or a distorted space, similar to Earth. In this scenario, if one were to travel perpetually in any direction, they would eventually return to their starting point, similar to circumnavigating Earth. The third hypothesis, the multiverse theory, presents an interesting idea, that our universe is only one of countless others. Imagine an infinite number of parallel universes, each existing with its own set of physical laws, constants, and properties. These universes might be entirely different from each other, operating independently, or they might be interconnected through complex systems, forming a vast and intricate multiverse. The James Webb Space Telescope, JWST, stands as an emblem of potential, illuminating the secrets that lie at the immense beginnings of the universe. This incredible instrument has an unparalleled ability to unwind the confusing past of our universe, permitting us to peer far beyond what was previously possible. The JWST is a mechanical wonder designed explicitly to observe the universe with remarkable accuracy. Its high-level capabilities stretch our vision to the earliest moments of the universe. In fact, a pivotal report published in the prestigious journal Nature revealed the JWST's discovery of 6 monstrous galaxies dating back between 500 million and 700 million years after the Big Bang. Incredibly, these ancient galaxies are far larger than anticipated for their early presence, testing the dominant speculations of universe formation. Moreover, their development in the early universe is truly remarkable. What's extraordinary about these discoveries is the degree of complexity in these ancient systems. This contradicts the assumption that galaxies form slowly over time. These huge galaxies display a level of intricacy comparable to our 13-billion-year-old Milky Way galaxy. The sheer number of stars inside these titanic behemoths outstrips our expectations, with each galaxy boasting a total mass several times greater than our Sun. Strikingly, one of these galaxies may even have a mass up to multiple times that of our Sun, eclipsing the already colossal size of our Milky Way. The JWST's unrivaled ability to explore the universe's hidden spaces relies on its use of infrared light, an invisible spectrum to the unaided eye. This surprising power enables the telescope to capture the faint emissions from ancient stars and galaxies, revealing immense remnants that have persisted for billions of years. Essentially, the JWST acts as a time machine, moving our vision back through the ages and offering a captivating glimpse into the universe as it appeared roughly 13.5 billion years ago. The continuous discovery of massive galaxies, anxiously nicknamed universe breakers, has altered our understanding. It's like rewriting history, a shocking twist that challenges many of the models we had laid out for early galaxies. Initially, we believed galaxies formed from humble beginnings, starting as small collections of stars and dust. They were thought to evolve gradually over time, increasing in size and complexity. However, the universe breakers have shattered these ideas. When the JWST data and its high-resolution images uncovered these enormous structures, these massive behemoths appeared seemingly out of nowhere, as if they had just been discovered, astounding our past understanding of cosmic evolution. Digging deeper, researchers used spectroscopic techniques to examine light across different frequencies. This analysis holds the key to unlocking crucial insights about these mysterious galaxies, such as their structure, size, and distance from Earth. It's like a vast investigative story, with light as the key to uncovering the secrets of these colossal entities. The amazing revelations from the James Webb Space Telescope have changed our understanding of the universe to extraordinary levels. This cutting-edge telescope, operated by a global team of space scientists, has recently uncovered a stunning discovery: the identification of the oldest and most distant galaxies ever observed. These galaxies transport us back to when the universe was only a small fraction of its current age, existing just a brief time after the Big Bang. The James Webb Space Telescope, out in the vast darkness of space, has been searching for answers about the universe. It's NASA's latest powerful instrument, capturing stunning images of stars, galaxies, and planets. Recently, It made a discovery so incredible that it could change how we understand the very fabric of the universe, leaving specialists puzzled and inquisitive about its true potential implications. When we study the universe, we begin with the visible universe, a window into the infinity beyond. This visible universe includes everything we can currently identify with our telescopes and space probes, including stars, galaxies, and other celestial bodies. However, it's just a tiny piece of the entire universe. Researchers estimate the width of our observable universe to be around 93 billion light-years. A light-year measures the distance light travels in 1 year, roughly 588 trillion miles, making the span nearly boundless. Around 13.8 billion years ago, the universe began with the Big Bang, a colossal explosion that triggered the Great Expansion. Since then, the universe has been evolving and speeding up, driven by mysterious forces like dark energy. Matter began to coalesce under gravity, forming stars, galaxies, and eventually planets like Earth. This continuous process shapes the universe's vast size, allowing us to observe only a small fraction of its infinite complexity. Even with the expansion, much of the universe remains dark and empty, despite how far we've come in exploring space. The majority remains concealed, even with the power of the James Webb Space Telescope. Huge portions of the universe remain out of reach, but its discoveries continue to reshape our perception, offering a glimpse into the unimaginable marvels that lie just beyond our sight. The infinity of space continues to amaze and inspire. However, with each groundbreaking observation, we are slowly piecing together an increasingly complex understanding of the universe's history and future. The James Webb Space Telescope is a tool that could forever change the way we think about space, time, and the very nature of our existence. The ramifications of the JWST discoveries extend beyond new observations. They challenge the very foundations of modern cosmology. If these gigantic galaxies existed so early in the universe's history, it drives us to reconsider current models of galaxy formation. For years, scientists have adhered to the idea that galaxies developed slowly, starting as small, dense groups of gas and dust, gradually growing over billions of years. The discovery of these massive galaxies, formed within the first few 100 million years after the Big Bang, presents a mystery that doesn't align with this slow development. This revelation opens up new questions about the nature of galaxy formation itself. How did such large, complex galaxies form so quickly after the universe's origin? What forces were at play during those early epochs that enabled rapid star formation and the development of galaxies on an enormous scale? These questions don't just challenge our current understanding of the early universe. They also push the boundaries of our knowledge of physics, especially regarding the behavior of dark matter and dark energy during the universe's infancy.